Hi everyone, David Maley here, and today I'm going to show you how to do stock price forecasting in a quick and reliable and highly accurate way. So today we're going to take this, which is the SPDR Spider S&P 500 ETF, also referred to as SPY, and I'm going to take 5 years of this data and show you how we're going to forecast it. So let's start first. Let's go down to the bottom of my screen here if this will work today. There we go. And I'm going to go right here and I want to show you, this is a quick method of how to do this. Now keep in mind that you're going to see people out there, a lot of videos that show you how to do log residuals of this, and that's not anywhere near as accurate. So I want to show you an accurate way of doing it, but I also want to tell you that it's more of a directional way. So I'm going to show you how to do this, but you don't want to look at it as daily. You want to look at it as like over a period of time, monthly or even a couple months, as to where is the market going to go. So you want to look at it more from that perspective in a directional method, okay? And then the other thing is, I want you to understand that we're going to show you a quick way here, but I'm also going to show you in the future here on a couple different, so this is going to be a multiple series of videos here. I want to show you not just this method, but I'm going to show you several other methods and even more accurate methods, and I'm also going to show you the log residuals method that people are using out there on the YouTube videos. So let's get started here. So first, I've got these libraries right here we're going to bring in. We've got Quant Mod, T-Series, Time Series, Forecast, and XTS. Okay, so you have to bring those in, and if you don't have them, you obviously use install packages of whatever it is and install that on your computer. Okay, so next what we're going to do is we're going to use the get symbols function right here, right below this right here. And I'm going to bring in 5 years of data. And obviously I already told you for the SPY, it could be for anything. You could pick IBM. You could pick any stock you want or ETF that's publicly traded and has their data on Yahoo and Yahoo Finance, and you could pull it right here. So I'm pulling, you can see right here, 2014-01-01 to current 2019-09-09. So it's like last week's. Now, it's a little bit more than a year's data. It's a year, or I mean, at 5 years, it's 5 years plus 9 months, okay? So now that we pull, once you pull that in, you just run this, then you run the class of it. I want you to see what class is this, what type of data are we pulling in here? And this will tell you quickly that it is XTS/zoo. Okay, so when you have XTS data, that means you're working with XTS objects, and what you have to understand with them is that it has the data column, and then you have an index field which has your dates in it, and it's a little bit different than data that you work with normally in a data frame or something like that. Okay, so next, let me open this up a little bit here so you can see everything here. What I want to do is I want to only use column 4 of this data. So when I bring this in, it's going to have high, low, open, close, and other data. As you can see across here, I have it all written down here. You have column 1 is the open, column 2 is the high, column 3 is the low for the day, column 4 is the close, column 5 is volume, and 6 is adjusted. So we just want to do with 4. I want the close, right? We want the close of each day. So to do that, we just do this. So we're putting in an SPY close prices equals SPY, comma 4, column 4. Okay. Next, what we want to do is I want to look at that and I want to see it. Now I don't want to see. I originally did it for the last 26 years. I want to do it for the last 5. So let's correct that and let's plot it. Right. So let's do this and run that. Now let's bring that. That's a little bit small. Let's bring that back and let's do a. Let's see this right here, this par MFRO, MF row equals C. Well, if we do that for 1, 1, that resets my screen. And let's do it again so it's a little bit bigger. We can see it here. There we go. That looks a lot nicer. So it's got our dates on the bottom, and it's got our values that it closed at over here. So it had a low of like below 180 on up to about 300 or so. And that's over that 5-year period. You got some big dips in there, and general over, trend is going up. So next, let's take a look at the class again. What does that tell you right there? XTS zoo, that's what I told you earlier. So we've got that in there. Next, what I want to do, let's bring this thing over this way. is I want to look at the ACF and PACF values. Why? Because PACF is going to give me a p-value. ACF is going to be a q, not a p-value like you would normally think of, but in the ARIMA world, when we're trying to forecast these things, I want the p, d, and q values, right? So there's three values, 1, 2, 3. I need either the first or the last or both. So let's see what we get from this. So what I'm going to do is I want to show two things. So I'm going to change this to 1, 2, and what I want to do is I want to run ACF and PACF. So those are functions you just run on your data, and then I'm just putting this, you don't have to put this main part here, that's your title for it, to tell you this is the ACF and this one's the PACF. Makes it a little easier to read it. So let's do that on this data, and there we go. So when you look at this, you immediately see that the first value in the ACF is 1, right? It starts off there and trends downward. And then the corresponding lag, these are lags by the way, in the partial ACF or PACF, which that's what helps you see up here, is 1 again. So clearly you have a lag at 1 on the PACF, which translates into a p-value of 1, right? So that's why I wrote in the comments up here, PACF gives P, ACF yields Q. So let's go down here. So now we test our findings on the original XTS objects data set that we have, right? So if we take this and we print the ADF test on it, this will give us our actual p-value, which is different than the p-value for the arimas, okay? So let's do this, Control and Enter, right? We run that, that's the Augmented Dickey-Fuller Test, ADF, okay? And out of that, we have a p-value of 0.2287. If we want it lower, so let's change that, that's not 0.95, 0.287. If we want it lower, then we have to differentiate, right? So we have to differentiate. So if we differentiate, that means we go from a difference of 1 to a difference of 2. Okay, at 0.2287, what you really want to have below 0.01, right, or 0.05. So let's open this up a little bit here, and let's go down here, and let's run our auto.arima and see what it suggests that the auto.arima PDQ values are, right? So let's see. Give it a second here. It's got to run. We've got a lot of data, 5 years of data. It's going to take a few seconds. There it goes. 314, it's telling us, is what it recommends. Now, that's with a high p-value. So what we want to do is we want to have a couple of fit values that we're going to graph, and then we're going to test their accuracy for our forecasting. So first we're going to use this little group right here. So what this is, we're just taking the same auto.arima we just ran right here, and we're putting it into fit A. And then we're going to display it here, and we're going to run it again to show you the exact value again to make sure it's all clear. So let's run this again, and I'll tell you each piece of this. The TS display is a function that just takes this and graphs it. Boom, there it is. And it gives you the model residuals, the ACF, and the PACF for it. Now, what's important here is these AIC and BIC values, which are clearly not that. Let's see, they are 5990 and they are 6038. Okay, so let's get rid of that. And we've got 314 is our auto.arima model. It's all in here. So the only functions you have in here really, I'm just running, it looks confusing, but it's really not. I'm just running auto.arima with seasonal equals false. I'm running TS display of the residuals of fit A, lag max of 40. I could change that and make it higher or lower if I wanted to. And then the title. That's all that is. And then below it, I'm just running the auto.arima again, just as I did above here. And it just displays it, shows it here, it gives us our values down here of 314, the BIC, and the AIC. Remember, we want AIC and BIC to be as low as possible, right? So now keep in mind with what we had before, right? We know we have a p-value of 1 for a custom ARIMA. So I'm doing the same thing down below. But you'll see instead of auto.arima, it's ARIMA with our data, right? And the order, the custom order I want to pick. So I want 1, probably a 2 here, because what? If I use 1, the p-value is a little bit high. So let's use a 2. Let's clearly define it as being a 2. And the next thing is just residuals, same thing, or the TS display of the residuals of the fit or the model, which is fit B. And everything else is the same. I'm just making it so it's clear as to what it is. And then what I have up against it is I want to have a fit C. Okay, so what if I use some, you can also play with the numbers a little bit in your arimas to see a better fit or worse fit. And so maybe what I want to do is I want to look at, remember the Q value is 4, right? So I'm going to leave that the same. But what if instead of a 1, we used a 5 and we leave this number as a 2? We can either do it as a 2 or a 1. We could leave it as a 1. You know what? Let's go back and use it as a 1. Or we could use a 2, that's fine. And then the third one, what I'm doing is the same thing for fit D, but I'm using 1, 1, 1. Why would I use 1, 1, 1? Because that is the auto default in almost every business intelligence application or program that you use. So what I want to do is show you the default value if you were to use something like Alteryx or use something like WebFocus or any of a number of tools, Power BI that has a built-in default. You can use that, or this will show you what that value would be. So I've got all 4 of them here. I've got 4 models I'm building, right? So remember, the first one's the auto arima. The second one is our custom arima, right? The third one is a guess on a different value based off of our auto arima. So instead of a 314, I'm using 514. And then the fourth one is the standard de facto default. So let's use all 4 of these, right? Now so this just builds the models, right? Next we'll plot them all. So let's do that, right? So we run them all, right? Give it a few seconds here. It'll run through. It's got to run through all 4 of them now. And it's all set to display if you want to display it like this so you can see each one, how they display. I'm not going to worry about that right now, but we can go back and look at them if you want. Let's go and look. They all look like they fit pretty well, but let's go and actually plot them out. So what I've got here is a par MF row, right? We've used that before. I've shown you what that is, but I want to have it 2, 2. I want to have 4 blocks, 4 graphs to compare them back and forth. Okay. What I've done is I've set a variable here, so I don't have to go and set each one to be 100 periods or whatever it is. If I want to change these periods quickly, I just change the value right here, and it changes it throughout them right here. And each one of these is just forecast the value, put it into a forecast holder or vector here, and then what I'm going to do is I'm going to plot that vector. Okay, so for each one. So if I run this for each of those 4 that I created, right? See how it's got fit A, fit B, fit C, and fit D in these? Okay, that's what we created before. So if I run that and I plot it out, watch this. Now it puts all 4 of them there, right? Now let's pull this back, right? Let's pull it back a little bit and take a look at what we got here. So the first one is right here, right? That's the auto arima. Look, it's going up. It's predicting that it's going to go up, our forecast, and we picked a period of 100 days, right? So 100 days is basically a little bit more than 3 months, okay? So if I look at the next one, forecast from ARIMA 124, remember that's our customary model. They're both going up and almost about the same. Now you want to look and check the numbers on the left to make sure they're the same, because sometimes you'll see them change a little bit, and like when I difference, it might go to a little bit less accuracy, but it's not really a big change in this. It's maybe a tiny bit different, but I mean not much. It's got a little bar here for 350, right? So versus this one does not. Maybe that's a little bit bigger in it because of the differencing, but it still looks pretty accurate, pretty close. Now let's go down below and look at these. So we got a forecast of ARIMA 514. Remember, that's the one we played with a little bit. That's actually got it going down a little bit, but that's just playing with it off the auto ARIMA. That's probably not as accurate. And then we've got this one here, forecast from ARIMA 111. Look at how similar. That's why I picked this one. I wanted to show you that. So see what happens here. This is the default. The default has it going almost straight line, but a little bit down. Same with this one, just a little bit down. But these two are going to be your more accurate. So now let's watch what happens here. So next, I'm going to use the accuracy function. So it's very simple. You just run accuracy of each one of these FCAST 1, FCAST 2, FCAST 3, FCAST 4. Remember, so this is not the fit of the actual model. This is the forecast of each of these models, right? So you got forecast function in here for each of these, right? And the H equals term is just this variable right here, remember? So I set it for 100 days. Otherwise, I could say H equals 100 through each one of these 4 times. Okay, so the forecast, let's open this up this way so you can see the forecast better, or not the accuracy, I'm sorry, and let's run that for all four, right? And what we're looking for in here, let's bring this up a little bit, is the MAPE, right? MAPE, all right, which is the mean accuracy of the percent error, okay? So what that means is you flip it. So in this case, you take 100 minus the score. So in each of these, you got 0.582, 0.584, 0.585, 0.583. So what that means is basically the first and the last two are going to be, well, no, actually, let's see. The first one's going to be 99.42. The next one's going to be 99.42. So let's correct this. Back, delete, and let's see, the next one's going to be 0.41 and then 0.42. But the best value, let's see, out of this, which is going to be most likely your first one here, that is your auto.arima actually. And then your custom ARIMA is close, but they're also close. It really doesn't matter. But the good thing is the best values are going to be your first two and actually your last one, surprisingly. So these two and this one, and the fact that they're all so close and you have two of them pointing up, I would say on this one your accuracy is going to be best with predicting either a straight line or up. So for your next 100 days, you'd be looking at a upward trend most likely. And that's what this does. So you're forecasting, you don't want to sit there and say, I want to know, and you could get out of this. If I wanted to, I could go and say, let's say I picked the custom ARIMA or the auto ARIMA, it doesn't matter. I could actually look at the actual values right here and look at the forecast. So if I hit forecast, right, see this right here, of fit A, H equals term, let's run that, right? There's your actual values. And what the forecast function does, let's go back to that, right there, is it gives you the actual forecasted point for each day, the low, the high for an 80% confidence interval, and the low and the high for a 95% confidence interval, right? So you can get an idea of where they should be, but you don't want to go, because there's so many outside factors, you don't want to go and say, okay, it's definitely going to be 298.597 on this day, and it's going to be 0.6521 on this day, and so on and so forth. You want to look at it as we just did over here, right? You want to do this, and you want to look at the trend, and you want to buy it based on the trend. So if you're looking to predict stock prices, this tells you right here for the next 100 days, you're looking at an upward trend, and you're going to have a more safe prediction looking at that. This one here says it's, possibly in a downtrend, but you have more pointing to an uptrend than a downtrend. So that's what I would look at right there. So basically what we did here is we showed you how to take and download data from Yahoo. So we got it from Yahoo Finance, right, by using, let's get this back here, the get symbols function. See that right here? We did that earlier. I showed you what libraries to load in. We're working with XTS data. We didn't have to go and take this data and stick it into a data frame. I will show you that in another video in a little bit here. But I want to show you really quickly how to go and forecast any publicly traded stock information or ETF or whatever you want that you can get through Yahoo Finance. So you can quickly get that. I got 5 years of data. You can see it right there. And we forecasted based on that the next 100 days. I could switch that from 100 days and make it 90 days. I could make it 365 days. I could do whatever I want there. Now keep in mind, even though you have high accuracy with these numbers, the thing is there's a lot of things that could change. For instance, Iran could go and send a drone attack like they did yesterday into Saudi Arabia and take out half of their oil fields. That changes things big time in the stock markets. You could have a terrorism attack. You could have some big tariff changes between the U.S. and China. You can have all kinds of different things happen, and that can greatly change it. So instead of looking at daily, we're using daily data, but we're trying to forecast out to a longer period and to get a trend. What we're really looking for here is directional trending from that, and that's what we have here. So I've got 100 days, and basically looking at that, You can take any of these models, but I'm going to take the first two and say we have a general upward trend over that period. So that's what I would do. If I were to buy stock today, I would look at this and say most likely, not guaranteed, but most likely it's going to go up over the next 90 days, over the next 100 days. All right, so that's with the SP. Now that's just with the SPY, right? The ATS. We did not predict for anything else other than that. Other stocks might look different, might be entirely different. And it'd be interesting to run some different stocks through this. But I want to show you how to quickly forecast stock price data in our studio and our from Yahoo Finance. So thanks again for watching. I hope you found this helpful. This is interesting stuff, especially if you're looking to invest in stuff, or you're looking at your mutual funds or your 401ks. You want to see, well, where's it going to be in 300 days? Where's it going to be in 100 days? It's interesting to look at it this way and say, oh, here, this one's going to do this, and be in an upward trend like this. So thanks again for watching. Please take a moment to subscribe, like, and share so other people can can benefit from this too. Thanks again, and have a great day.